Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. At Rapid TCT 2024 in Los Angeles this year, the state-of-the-art in additive manufacturing was on display from material and machine makers worldwide. Additive has long been known as an outstanding way to make single or low-volume production of intricate parts, but what about the big mass production industries like automotive?
Mass production for automotive applications. We're used to a world, and you and I both come from the industry, we're used to a world of tens of thousands of units, basically. A production run's a real production run. You can justify $100,000 to cut an injection mold or make a stamping dies.
Yeah, I mean, absolutely. You know, the low-end scale and the smaller scales, absolutely, that's a shoe-in fit, right? But in these medium scales, I think there's two factors at play. One, there's always a crossover of how many parts you're going to make versus how much cutting a tool costs, and that line continues to kind of move as additive advances, becomes more efficient. So that number is getting bigger and bigger before that crossover point really happens. The other thing is you're talking some of these niche markets or niche model examples where they only need 5,000, 7,000 of these. There's also a premium associated with those models, and additive again is a shoe in there because the customer can see the performance, they can see the value add, and it's right in a quantity where they're happy to pay for it. They see it, and it fits into what additive's capable of doing right now.
With additive, you've got the ability to lightweight a part because you can put a sort of a lattice structure or vacuum on it and maybe move up the food chain a bit and use a more expensive material. Is that sort of some design flexibility?
Yeah, big time with the design flexibility there. You know, using a more exotic, more expensive alloy, but taking weight back out of it, you can actually be cost neutral, if not a little bit lower, if you do it right. And you know, the application has to lend itself to that.
We're seeing a lot of interest from people with regards to how do we do that mass customization, right, for those more specialized vehicles, more discerning customers, but also for maybe high temp applications, you know, that these more exclusive, higher performance engines require. And that's where we see some refractories, some copper alloys really being of interest. And I think that's where a lot of at least the conversations we see are from the OEMs trying to figure out how they can take, and some of these become real differentiators for them. And so therefore, how do they bring that technology in-house, be able to not just do it internally, but also protect that critical IP that's coming along with it.
Dave, on the automotive side, additive has been a preferred process for very high-tech industries like aerospace, you know, for some time. Automotive, that's higher volume. It needs lower cost materials in general. However, there are some who say that jigs and fixtures is that there's a soft spot for additive in automotive beyond simple high-tech part making. Where's it going to be with additive?
Absolutely, we're finally getting there with the speed of additive, or metal additive, I'll say. It's been there for the low volume automotive manufacturers for a while, the Ferraris and McLarens, things like that. But it's finally the OEMs of everyday cars were able to produce direct components, and so that's, you know, examples of what we've got here on the table, as well as, like you're talking, the molds, things like that. We've seen it used for tire manufacturing and getting better treads in tires that previously were not able to be manufactured, as well as just the high-speed stamping assemblies of conformal cooling that can be printed into parts and allow the automotive world to reduce costs.
John, in automotive manufacturing, additive manufacturing, basically, it's been a big thing for jigs and fixtures, for tooling, for supporting technologies and effectors for robotics, basically. But for part making, the assumption has always been, well, you know what, if I need 10,000 parts or 20 or 100,000 parts, I'm going to injection mold them. I'm going to cast them. I'm going to stamp them the same way. But is there a way in the future, do you think, that we are going to see true high volume production come out of larger format, perhaps metal additive machines?
Yeah, that's definitely going to be the case. All of the North American manufacturers are very interested in additive and doing a ton of research and actually coming to us with a plan and saying this is what future machinery needs to look like in 5 years and 10 years. And they're actually even aligned in some cases with aerospace companies where they have some informal working groups trying to make sure that equipment needs are aligned between the two verticals, so that as a machine OEM, we are making machines that touch multiple industries. So that's very important. And if we look at like this part here, this is a great example of stacking work pieces on top of each other to maximize efficiency and get more parts in the build at the end of the day. And as we come out with larger and larger machines, they're going to be able to stack more parts in the build at the end of the day, and that can definitely increase throughput and productivity.
There's a lot of money to be made in what we used to call the death zone of production volumes down there. Not supercars that are made maybe a dozen a year, and not where, say, Toyota Camry is, you're going to make $750,000 a year, but high margin, special versions often of production vehicles.
Yeah, additive's perfect for that. That's kind of why additive began. That's what it's used for. When you have those purpose-built vehicles, something of a specialty application, short run, customization, you want to be able to manufacture something in the right material, in the right property, in the right fidelity, and then do it in a way that if you eventually want to go to tooling, if the product is a raging success, great, go to tooling in the future. But additive allows that journey for fast prototyping, fast time to market, and automotive is a perfect space for it, and we see lots of success there.
At Rapid, one of the themes in automotive was the flexibility of additive as a production and tooling technology. The traditional 4 or 5 year lifespan for major automotive platforms is under pressure, especially as electric vehicle manufacturers are changing the traditional assembly process.
Cameron, 3D printing historically has been used in the design office everywhere, of course. For 20 years, it's been a great way to make prototype parts. Maybe short runs or sort of functional prototypes, something you could sort of proof of concept stuff. The big leap has always been, can we make production parts with this, say in the automotive industry? But there's an intermediate step involving jigs and fixtures where this thing is really kind of a sweet spot, isn't it?
Oh, absolutely. And in fact, I like to always point out, remind people that making jigs and fixtures is a type of production, right, in its own light. But it's definitely the current biggest space that we see our customers leveraging 3D printing and seeing a lot of value, and it's just exciting to see that it's being used more and more in that space for sure.
So it's you might invent something new, but you can't get it out there because you have to wait for the natural development cycle to turn around on there. Is 3D going to allow us to break out of that kind of mold of we have to wait for like a certain development cycle before we can add something new and just go ahead and just run as we go?
That's a great question, and I would say just the nature of what 3D printing as a manufacturing technology can do to the mindsets, I think, of our design engineers and manufacturing engineers, I think could lend to a change in what is legacy thinking about that rigid structure of a product rollout. And then certainly in the smaller EV space with emerging car manufacturers, they're not burdened by that legacy, right? And so they're a lot more dynamic and iterative in their processes today. So.
In the transition from 3D, from a prototyping short-run technology to a true mass production technology, are we going to need a shift in the existing technology of part making, a new way to code this thing, or a new mindset, or all of the above?
You're going to see a little bit of all of the above. And from a manufacturing standpoint, like you said, these technologies are very, very efficient. They're also have been driving the price down of the end product. So what do you do, or how do you drive the price of the end product down? In additive, we need a couple of things. We need materials that are going to be able to drive that price down because they're now at scale, so adoption. We also need systems that are going to be industrial grade and production speeds. So are we going to get to a 30, 60-second cycle time in injection mold? Well, I hope so. But I do see the technologies also as complementary to each other. So looking at things like bridge production and full production, I do think are well within the possibilities of additive in the future and now.
The comparison has always been with technologies like injection molding, which is well characterized for almost a century now the same way. And we know it's a very fast way to make things. It's also a very expensive way to make things on the upfront tooling costs. So you've got a lot of sunk costs in a cavity, multi-cavity injection mold.
The first thing to say is that we're making injection molding tools, and we can make injection molding tools quite inexpensively that can run thousands of parts, which is a real revolution. And can, in the long term, change injection molding, because instead of spending months and hundreds of thousands of dollars on a tool, you can spend days and, sub $1,000 and make multiple tools and then change things. Having said that, there are enormous advantages to additive processes as compared to injection molding. And with our production speeds and our cost models, we can compete certainly for the low-end number of parts very effectively against injection molding, but with better geometric freedom and being able to change the designs on the fly.
We've seen additive as a prototyping technology forever. We've seen it move into short-run part making for some specialty manufacturers. We've seen the sports car guys and the racing sort of guys get into it. And it's, of course, the holy grail, of course, is you want the thing in Toyota, in GM, and in Ford. And you want to make 100,000 parts per week with this thing.
We're already doing this today. We put parts into General Motors, a bunch of different individual components on the Blackwing, and actually now individual components on the Celestique. Actually, just last week, we won an award, one of our customers, for the first safety critical parts at General Motors. It's the D-ring that holds the seatbelt in place. That was made on our printer through very rigorous quality standards, PPAP standards. We're developing the expertise to have the right process to go and evaluate these things, and that will just create more types of applications that can be identified because the barriers of entry won't be too high. We're starting with these luxury vehicles, moving down to premium vehicles, and then ultimately I think we'll be into the consumer market, high volume production with high value components. So I definitely am thinking that we're going to be optimistically there by the end of the decade.
In the automotive industry, there's a lot of money to be made in shorter runs of special edition versions of mass production vehicles, and these present a unique tooling and part-making challenge. Volumes may require conventional mass production tooling, like injection molds or stamping dies, but without the expense and time of tools with 500,000 or 1 million part durability.
We know that historically 3D printing, additive manufacturing has been sort of reserved for the design office and for doing things often in not the material that you run production in. Right. But we're now moving into a world where it's possible to actually do short runs of production parts with this technology or prototype in the same material that you're going to run, say, an injection molded part.
Yeah, absolutely. Now we're getting into a situation where you can 3D print the tool, the injection mold tool, and then shoot parts in the actual material that you want to use in final production. So I can one day design a mold, print it that same day, shoot it that same day, and put parts in people's hands in very, very fast turnaround with very low cost, very low investment. I'm able to shoot anything from high temperatures, like high temperature materials like PEEK. I can shoot parts with that use metal injection molding material, and then I can actually get metal parts after I do a sinter and a debind and a sinter.
Sure, and that's interesting. Historically, of course, on intermediate volumes, 1,000, 1,500 pieces, that was sort of a death zone because you're not going to cut metal for hard tooling for something like that. Yeah. But by the same token, you still need a Class A finish potentially for an automotive customer in there. So can you see a world with this kind of technology where we can just implement changes to the part almost on a running basis and not have to lock something in for a 50,000 or 100,000 part run?
Absolutely. I mean, one of the great things with this is it with the amount of time it takes to make a part, I can print 6, 7, 8 iterations of the part. I can change it on the fly. Once I've got it nailed down, once I'm really happy with the final product, then I can go cut metal for my thousands and thousands of parts.
Special runs, short runs, highly profitable for the manufacturers down there. Cadillac Blackwing, Harley Davidson F-150, Roush, the sports car guys. Everyone wants a special edition of something because it's customers love it. Volumes, however, are below those that we would typically think of for mass production technologies like injection molding or stamping, for example, now.
Yeah, I think that's where things are going. So I've mainly been looking at procedural design for additive. And so that basic idea allows you to add parameters and add design constraints, and then just letting the system design the part from that. But a lot of that, again, like you said, you can add parameters to the specific driver or the specific requirement for that. But also, you're allowed design freedom, so it may not even just be a limited run of 50. It could be literally each individual copy is unique and distinct for the consumer.
Now, you mentioned, of course, generative design, even AI-driven design at this point. The consumer needs, of course, determined by that conversation he's having on the showroom floor, if you will. Do you see a world in which somehow that you pipeline or connect that directly to the manufacturer in almost a real-time basis? You could production schedule that as soon as they sign the dotted line?
Yeah, I see a future where it would be like a video game, where you configure your own character, you configure your own avatar, and can just create your design on the fly for something like that. And there's definitely more software solutions kind of moving that direction to kind of allow that mass customization. You already see it on some car manufacturing sites where you kind of go in and you can configure it from the factory.
Additive has been the future of manufacturing for about 2 decades now. I mean, the thing existed, of course, in the engineering design office for prototyping technology, and for years people said, wow, if only we could sort of scale this up and actually mass produce the parts this way. Now, people who actually know automotive manufacturing know that there's a lot between raw material and finished part, and a big part of that are jigs and fixtures, and a big part of the costing there are jigs and fixtures. Is that the sweet spot for additive in automotive mass production?
It's certainly the low-hanging fruit. So what's happening today, you need to put a car together.
We've had to do that for a long time. That efficiency needs to improve, because if you can get 10 more cars out a day and they're selling at 100K, just roughly that's $1 million a day more for that plant. So what could we do in additive to enable that manufacturing and assembly? We could build lighter tooling that's cheaper to make, faster to make, more ergonomic for the operators, safer to use, faster to the operator's hands, maybe customized to that application. And so what that does is enables the auto manufacturers to implement new technology to get more cars out the door. That's certainly the first step where you need to leverage additive. It's hard to jump right to, oh, let's make a production part for an F-150 that has 50-second takt time and there's one every minute coming off the line. That's not really the sweet spot for additive. The sweet spot is lower volume, higher complexity, maybe aftermarket things on the production side, but certainly jigs and fixtures is where I would recommend any automaker start. Look at your plant floor. What can you do to be more efficient there?
While we generically call the industry automotive, for vehicle manufacturers, off-highway and military contracts represent a large and important segment. Both segments use tracked and wheeled vehicles, and today there's a renewed emphasis in wheels and pneumatic tires in very challenging applications such as armored personnel carriers and the giant machines used in open-pit mining.
We think of the automotive industry largely as cars, trucks, buses, but automotive industry is actually larger. Military are a huge user of automotive technology on wheels and tracks, and militaries are more mobile now than ever before. But the machines are sophisticated, complex, and they break. They get shot at and they frankly break down. We're seeing now a move towards sort of mobility that includes the ability to manufacture things like replacement parts in the field. Additive, this seems like a natural technology for that.
Yeah, it is a natural thing for additive to do. So the challenge with the military, the challenge with the industrial sector, heavy industrial sector, is they've got these very expensive bits of equipment. Armoured personnel carriers, think of mining trucks. What happens when they go down? It can be very costly or it can put lives at risk. So what you really want is to be able to build these parts very quickly, but at the point of need. And that's the sort of thing that additive manufacturing and advanced technologies can actually do. It's something we haven't been able to do for the last 20 or 30 years. But with the advent of additive and advent of new technologies, AI, quantum, all of those things, we can now do that at the point of need. So it's a fascinating area in the world of automotive. As you can probably tell from my accent, I'm from Australia. So Australia is driven by mining. So it's an area that we're very passionate about and we're involved in. And it's exactly that. And maybe they're down, if something goes down one of their big conveyor belts, it might be $1 million an hour. And then it might be a part which is a $50 part. But that $50 part is costing them $1 million an hour. So they're like, right, how do we get this part quickly? Now, if you can manufacture that part at the mine site, which you can now do, it needs to be strong, however, it needs to be robust, it needs to be reliable. So it's going to be a metal part. But you can now do that in the field, and that's really where the industry is moving towards, or certain elements of the industry are moving towards. How do we help these heavy industrial sectors, mining, defense, oil and gas, marine, this heavy, expensive infrastructure? Let's keep it going. And that's really where additive can really help.
AI is definitely at play in additive part making in every industry, and that's also true in automotive.
Now, in aviation, of course, fidelity, part performance, very important, and they're willing to spend money and use high-strength materials, high modulus materials as necessary to get the performance they need. Automotive, very cost-driven, higher volume, often commodity materials. Their compromises must be made at the same time. Is there a difference in designing for a high-volume application like automotive compared to like the intricacy of aerospace?
Yeah, completely. So in aerospace and automotive, these are the two industries where we see the biggest adoption. As you said, the automotive is all about increasing the efficiency at a cost per parts basis, while in aerospace, the quality assurance and certification, for example, could be the biggest cost overall, because the volumes are not as high as in automotive. And again, software plays a critical role, both in terms of material reduction, making the parts more cost effective, as well as eliminating the need for process monitoring or quality assurance.
So where does additive fit in the automotive space going forward? Well, judging by the experts, additive manufacturing technology is getting faster and more capable, while the automotive industry itself is moving away from long production runs of standardized products and towards mass customization. It's a best-case scenario. A highly flexible production technology is converging with an emerging consumer need in a massive global industry. Well, that's it for this episode of Industry Insights and Trends. If you're interested in learning more about additive manufacturing in the automotive space, we have an extended version of this video found exclusively on engineering.com TV. Click on the link in the description below for additional in-depth interviews where you can discover more about the latest trends in industrial 3D printing from our subject matter experts. Thanks for watching.